We've been talking about using the right tool for the job, and part of that is understanding the strengths or weaknesses of the tool you're trying to use. So let's spend a moment talking about strong versus weak typing. Now, regardless of whether or not this story is true, I love this story. As the story goes, President Abraham Lincoln was invited into this woman's parlor, and she brought out her best china and served him what she thought was exactly the drink he was looking for. And he took a sip and politely put the cup back on the saucer and handed it to the matron of the house and said, "Excuse me, dear lady, if this is coffee, will you please bring me some tea? If this is tea, will you please bring me some coffee?" Now, the reason I love this story so much is not that President Lincoln was taking a strong stance saying coffee is better than tea any more than we would take a stance saying Java is better than JavaScript. It's not that one is better than the other or worse than the other. They're just very different. Coffee and tea have similarities in that they are both hot, steamy caffeine delivery devices, but they also have differences as well. So being able to understand the strengths and the weaknesses, the similarities, and the differences between these solutions is what we want to talk about right now. And rather than just focusing on strong versus weak, I also want to add another dimension to this discussion: static versus dynamic. Now, when we're talking about something that is strongly typed, it means variables have a very specific data type. They're strings or numbers or booleans. Weakly typed means we can modify them. But static versus dynamic determines when we can make these changes. If something is statically typed, it means those data types are set at compile time. And if they're dynamic, it means they can be changed at runtime. So when we say that Java and C# are strongly statically typed language, what it means is not only do we declare our variables to be of a specific type, that those data types are determined at compile time and many times can't be changed after the fact. JavaScript, on the other hand, has a var keyword, so we know that we have weakly typed variables, and in fact, because JavaScript is not compiled, it can be dynamically changed at runtime as well. Here's another way to think of it. When I think of variables in Java, I think of an egg carton, because an egg carton is the perfect variable to hold egg-shaped data. But that egg carton is probably not the appropriate variable to use if you're trying to hold waffles or bacon or coffee. So we can see that as I move in through Java and I'm declaring variables, I have string-shaped variables, I have date-shaped variables, I have person-shaped variables. And in fact, when I try to put a string-shaped data in a person-shaped variable, I get the lovely class cast exception. You put the wrong shaped data in this particular variable. And there is no greater irony, or maybe appropriateness, that a class cast exception is a deeply typed data type as well. We can see that class cast exception extends runtime exception, which extends exception, which extends throwable, which ultimately extends object. So we can see that Java is not just a little bit strongly typed, it's types all the way down. And that works until you're presented with something like this: a duck-billed platypus. How are you going to model this in your precious programming language, Java? We have something that is a mammal. So class platypus extends mammal, but it has a beak. All right, well, class platypus extends bird. It is warm-blooded. All right, class platypus extends mammal, but it lays eggs. Okay, class platypus extends bird. This is the only mammal on the planet that is poisonous. So all of a sudden we're left with this thing that doesn't cleanly fit into any of these rigid, strong, static type languages. And a wise man once told me that we are modeling the world in software, and your model should never be better than the world it's trying to represent. And so we see with something like this, I'm a big fan of dynamically typed variables and weakly typed variables in JavaScript because it gives me more flexibility. My variables are now buckets that I can pour any data type in that I'd want to. Simple scalar types like strings and dates and numbers, but more complex types like object literals and even functions. So no, I haven't said at this point that JavaScript is typeless. I've said that it's weakly typed. And I will say officially on the record that I think you'll be a much happier person if you ignore data types in JavaScript altogether. Because so much of the confusion and the consternation and yes, the bugs that are associated with this particular language have to do with, truthiness. Do you use 2 equal signs or 3 equal signs? Well, the question is, do you want true equality or just truthy kind of equality? Now, as a Java developer, and I told you this up front, I was a Java developer. So as I came to JavaScript after the fact, begrudgingly, I said things like, okay, 1 equals 1, and that was true, and I was happy. And then I said string JavaScript equals string JavaScript, and that was true, and I was happy. And then I saw something like 1 equals true, and I got true. I said, well, all right, let's consider this a little bit further. If 1 equals true, then 0 must equal false, and in fact it did. And I was happy again until I noticed that an empty string was false as well. And I noticed not just an empty string, but the string 0 was false as well. And I was less happy, but I was cautiously optimistic that, all right, I get what's going on here. So I explored it even further, and I tried to see if the string true equaled true, and it did not. Neither does the Boolean value false equal the string false. And then I said, all right, let's really explore this. So what you're telling me is that 0 equals the string 0. Yes. And you're telling me that 0 equals an empty string. Yes. So by the powers invested me by the transitive properties of JavaScript, I've now determined that an empty string equals the string 0. No, it does not. So what are we left with here? How do you explain this madness? Well, what's going on there is this double equal sign is doing truthy equality. And what we mean by that is it's doing type coercion. It is literally changing the data type of one of these values and trying to do equality on common data types. So while this sounds good on paper, in practice, you find it can be incredibly frustrating because it's non-deterministic, or at least it appears to be non-deterministic. I promise you it really is deterministic. There is no randomization going on in this. This is the page from the ECMAScript specification, and I wanted to show you that this equality algorithm fits on a single screen. It is deterministic, and as you read through it, it says, all right, if X is a string and Y is a number, we'll try to convert them to numbers and do equality that way. If X is a string and Y is a Boolean value, we'll try to convert them to Booleans and compare them that way. So this equality is deterministic, if not a little bit confusing and unexpected when you get down into the weeds, so you are much better off ignoring types in JavaScript and simply using 3 equal signs. And when you use 3 equal signs instead of 2, it's clearly 1 better than that. I love it when Java programmers come in and say, well, what would I get if I use 4? 4 equal signs. You get nothing. That's crazy talk. Why would you even suggest it? But when you use 3 instead of 2, what you get is you move from truth equality to strict equality. By adding that extra equal sign to the evaluation, 3 equal signs means please stop doing the type coercion and please treat these as the data that they are. Don't do any transformations. And while you might think I would be upset with all the falses I get, in fact, I am much happier because, in fact, what I am looking at now is something that makes a lot more sense to me moving forward.